If you've ever built any kind of LLM or GenAI type application, chances are you've got it working locally, and eventually you're going to want to share this with other people or even push this into production. Now, once you set this up locally, there's all kinds of dependencies and requirements, and trying to show someone else how to do that or get it set up in the same way on another computer can be a massive nightmare, especially if you want to go into production. So in this video, I'm going to show you a solution to that, which is using Docker to containerize your GenAI applications so that all of the dependencies are saved and you can really easily run your apps no matter what your hardware configuration is. This is a really cool video. It's going to be really useful for any of you that work with GenAI apps and have followed even some of the other tutorials I have on this channel where we're building things like GenAI chatbots, RAG applications, etc. So with that said, let's get into it and learn how we can use Docker to deploy and containerize our GenAI apps. So let's dive in here, and I want to start by thanking Docker for partnering with me on this video. They've been really helpful in creating the video and providing a lot of documentation and resources so that I can really explain this to you in the best possible way. Now, what we're going to start by looking at is something known as the Docker GenAI stack. Now, this is a collaboration between Docker, Neo4j, LangChain, and Ollama. This is a way that you can actually deploy a GenAI application with just a few clicks and really minimal configuration, which we couldn't say before because typically it takes a lot of different dependencies, a lot of setup, and it was a huge headache to actually get these GenAI apps out into production. With Docker now, we can containerize the various different components of our application, and I'm going to show you later in the video exactly how we do that, starting completely from scratch. Now, the GenAI stack, as I said here, uses Ollama for management. So for the various LLMs, this means you can actually run your LLMs locally. If you're not familiar with Ollama, something again that allows you to run LLMs locally on your computer rather than relying on something like ChatGPT or GPT-4. Next, it uses Neo4j. This is a database and also a knowledge graph for the LLMs. Again, this can run completely locally on your own computer. And then we use LangChain for the orchestration. And then this uses Docker, of course, for doing all of the containerization, deployment, etc. Now, what I'm going to do is go over here to this Docker GenAI stack repo. This is something I'll link in the description if you want to check out for yourself, but this just demonstrates to you how you can run all of these different services on your own computer with really minimal configuration. So this is a repository that has Ollama configured, Neo4j configured, and actually just serves you a few different GenAI applications. So it has a support bot, Stack Overflow loader, PDF reader, etc. And the purpose of this repository, at least why I'm showing it to you, is so that you can see with just one or two commands, you can actually get all of this running on your machine without having to do a ton of tedious setup. So what I've done to demonstrate that to you is on the right-hand side, or on my VS Code window here, I've just cloned this repository, the GenAI stack. Now, all I've done is just create an environment variable file here, based off the example that they had, and I simply ran the command docker compose up. Now, this just uses the Docker compose file that's provided in this repository, which spins up all of the various different services or containers that we need to run this application. Now, I know it looks a little bit complicated, but don't worry, I'm going to show you again a much simpler application in a second and how we do this completely from scratch. This is just an example of something that you could do, and again, how fast it is. So what I'm able to do now is view a few different applications on my computer. So you can see that I have a support bot, a Stack Overflow loader, PDF reader. So what I'll do is just go to one of the applications here. This is the Stack Overflow loader. Again, notice running localhost on my computer. Now, this allows us to load in various questions and answers from Stack Overflow that match a specific tag. So what I have done previously is I just loaded in Python lists. I'm not going to do this again because I already loaded it. And this now allows me to go to the main bot UI, which is just served on a different port. And I can now ask questions about the various Stack Overflow questions. So I can say, hey, what is an index error in Python? And now it's going to go and look up that information for me and give me a response. So you can see here I got a reply, and it's showing me the various different errors from Stack Overflow that are relevant to this question using something known as RAG, which is Retrieval Augmented Generation. The important thing here is all of this is running on my own machine, and again, I didn't really need to set anything up for this to work. Now, another application that this provides, just as a demo, is something that allows you to chat with your PDFs. So I'm going to upload a PDF here, and then I can ask questions directly about that. So I just uploaded a PDF here, which is just my receipt for a QuickBooks subscription payment. This should be for about $60. So I'm just going to ask the LLM how much was the payment for, and it should be able to actually use this PDF and give me the reply. There you go. You can see the amount was $62. Obviously, I could ask this something that's a lot more complicated, but just a demo of how this works. So that's a quick demo of the GenAI stack, but I want to quickly walk you through a few other really cool features that Docker has released recently that are really useful and you guys can find some value from. Now, the first feature is profiles. Now, if you've ever worked with some complicated repositories before, you may have actually written multiple Docker files or Docker Compose files for the different types of configurations or different type of hardware you might be running on. A good example of this is running on a CPU versus running on a GPU. Now, Docker's come up with a solution for this, so you don't need to repeat a ton of code, and they've introduced profiles. Now, this allows you to actually just specify a flag while you're running the Docker Compose file to indicate what profile you want to run with, and you can do some different configurations or setup based on that profile. So in this case, you see that we have Linux, and then we have Linux GPU. So if we want to run using an NVIDIA GPU, which is specified right here, which you would want to be doing, especially if you push this into production, then you would simply utilize this profile. However, in development, maybe you're working on a machine that doesn't have a GPU like I am right now, or at least with a non-compatible GPU, and in that case, you can just use the default profile, Linux. So if you want to actually run the profile command, I'll link some documentation to you in the description, but you can see it's as simple as just specifying what profile you want to run, and now all of a sudden, you can change the configuration and the way that Docker is going to work with just a single change to your Docker Compose command. So that's the profile feature, but another cool feature you'll find useful is the watch feature. Now, if I scroll down here in the Docker Compose file, you can see that we have a section labeled xdevelop, and then we have watch. Now, this is another new feature that Docker has added that allows us to actually watch specific files and then rebuild certain containers whenever any of the contents in those files change. Now, this is really useful because before you would have to manage which containers you were running yourself, and you'd have to know which ones to restart based on what you were changing while you were developing certain parts of your application. In this case, you simply write in the watch, which is done right here, and now if any changes are applied to bot.py, pdfbot, etc., we can automatically rebuild this container without having to rebuild all of the other containers. Now, we can do this in all of the containers. For example, if we go down here, you can see there's a different watch, and all we have to do in order to actually utilize this feature is just run a slightly different command. So I'm just going to stop this here, and I'll show you the command that we can run. So there's a few different commands here, but I can go with Docker Compose Watch, and when I do that, it's now going to use these watch fields that we've declared, and if I make any changes to these files, we'll automatically rebuild that container, or whatever it says here. We can sync it, we can rebuild it, there's a few different options. So hopefully you just learned a bit about the GenAI stack and some useful Docker features you can take advantage of. Now, I know a lot of you will be asking now, okay, that's great, I understand GenAI stack, but how do I actually do this for my own GenAI application? That's why I'm going to show you now how you containerize your own GenAI app. So without having the Docker files created, how do you actually go through this process? Now, there's some great documentation on the Docker website, which I'm going to link in the description, and I'm just going to follow along with it and kind of walk you through step by step so you understand what we need to do in order to get this running. So click on this link in the description if you want to follow along with me, and what I'm going to do is copy this sample repository, which has a very simple LLM app built that uses Streamlit for the UI, Ollama, and then Neo4j. It also uses LangChain. Now, this is a Python-based app, which I'm sure a lot of you will probably be building. So what I'm going to begin by doing is just cloning this repo. So let's just paste this command in. And then once that's done, we can go inside of here and we can start initializing kind of our Docker files, the compose file, the Docker file, etc. And I'll show you a really unique command that can do that almost instantly for us. So the repo is cloned now, and what I'm going to do is just cd into it, and you'll notice here if I click into it on the side that we just have some basic Python files, an environment variable file, etc. We don't have anything we need to actually kind of start this with Docker and deploy it with Docker. Now, fortunately for us, there's a really useful command called docker init that we can run that will actually create all of the necessary files for us. Now, in order for that command to work, we are going to need Docker Desktop installed on our machine. So what you can do is simply go to Docker Desktop. You can find the correct download link, whether it's on Mac, Linux, or Windows, and just make sure you have that on your machine before you start actually trying to initialize this command. You also want to make sure that you're running Docker Desktop. So if you're on Mac, for example, you can just open up Docker, and then as soon as you open it, it should actually start the Docker engine. If you're on Windows or Linux, same thing. You just have to open Docker Desktop, and then it should run everything for you, and you should be able to initialize this command. So I'm going to run docker init from inside of this repository, and what this will do is go through kind of some basic configuration for me and allow me to configure my app. So I'm going to say that this is for a Python application, which has been automatically detected. It's going to ask us what version we want to use. I'm just going to go with the newest version here. The port, I'm going to go with the default port, and for the running command, this is what you'll actually use to enter your application. Obviously, this will differ depending on the type of app that you have. Now, in our case, we're just going to go back to the docs here, and you'll see that there is a command that we can copy. So it's right here, Streamlit run app, and that's because we're using Streamlit for our UI. So that's the command we're going to use. So let's paste that in here, and it just specifies the server address and the port. Okay, so now that we've done that, it's actually created the necessary files for us. So we have the docker ignore file, we have the compose.yaml file, which is where our various services are going to be defined. We have the Docker file, which is usually a huge pain to write, but now it's just completely done for us. And we even have a readme docker.md file. So that's the docker init command, super useful for getting up and running really fast. And now if we just make a few really minor changes, we can actually run this application on our local computer. So actually, I lied. All we need to do is just type the command docker compose up and then -- build. What this is going to do is use the docker compose file, which is already created for us. It's going to spin up the container that we need, which will be running our application. And even though this hasn't containerized everything for us yet, it's just showing you kind of baby steps in terms of getting the application running. So this here will just actually create a container for the user interface or the server. So for kind of like the Streamlit application, it's not going to containerize Ollama or the database or some other things that we need if we want everything to be running completely locally. But you'll see what I mean in just 1 second once this gets loaded. So you can see after running this command, the Streamlit application now is running within the Docker container. So I'll bring it up for you and you can see what it looks like. So this application you see here is actually the chat with PDF application that we looked at previously. Now the reason why it's giving us these fields here and saying we need a Neo4j URI, username, password, and we need one of our LLM models, so either the Ollama base URL or the OpenAI API key, is because we haven't yet containerized those and made those services that are accessible to this app. Now we're going to do that in just a second so you can see how all of this runs completely locally, but at this point if you wanted to, you could connect to a remote database, you could connect to OpenAI and utilize something like GPT-4, and you can have this app running on your own computer. You're just going to be outsourcing some of the components and not entirely using the Docker containerization. But what I want to do is I want to go and actually containerize the rest of our components so you can see what that looks like and how we do the deployment completely locally. So what I'm going to do now is stop this application by hitting Control-C. Then I'm going to shut down the containers by doing docker compose down. And then what we're going to do is containerize the other services like the database and Ollama so that we can run all of this without relying on some third-party dependency. So I'm going to say docker compose down just to remove these different containers that we don't need. And now what we're going to do is go back to the documentation and we're going to follow along with the next page. So if you scroll down to the bottom of the docs, you can press develop your application. That's going to bring you to the next step, which will bring you to this page right here. And this is going to show you how you add a local database and how you add a local or remote LLM service, which is exactly what we want to do. Now to start with the local database, what we need to do is we need to change the env.example file to be .env. Now this is going to provide some of the environment variables we need for the database. So what we'll do is go over here to our repository, and where it says env.example, I'm just going to rename this to say .env. And if we go in here, you can see that we're going to have a few different configuration options. So we have the URI, the username, the password, the Ollama base URL. We'll change some of these in a second, but at least now we have the environment variable file declared in the repository. Now we're going to go back and let's see what it says next. It says, okay, if we want to add this database, then we need to copy the following. So let's copy all of this stuff right here. And let's go over to the docker compose file, so compose.yaml, and let's simply paste this in. Okay, so that's pasted. You can see that we have the environment variable file. It's depending on this database being healthy, and then we have some information for the database. And notice that we're using those various variables from our environment variable file. You don't have to worry too much about exactly what I'm copying here, but this is going to create the database service for us and run it all locally. So let's save that file and go back to the docs and see what we need to do next. So we can run this app now, and if we do that, we should see that it's no longer going to ask us for the database information, or at least it will already be connected, and then the only thing we need next is the LLM. So I'm just going to rerun this with docker compose up -- build. So now you'll see that Neo4j is running, which means the database has been created. And if we want, we can go back to the application and we can see the state of it now. However, what I'm going to do is go to the next step in the documentation, which is going to be adding the LLM. Now, I want to have a local LLM here, which means I want to use Ollama. So let me explain to you how we do that. Now, in order for Ollama to work within our Docker container, we're going to need it running on our local computer. That's because Ollama will have some really large models, and we wouldn't want those models to be installed every time we spin up the container. Instead, we want to have it on our local computer and then just access the server that's running on our local computer that's kind of serving these LLMs. So download Ollama if you don't already have it, and then what we're going to do is open up our terminal, and we're going to run the Ollama command to pull the model we're going to use. So we're just going to say Ollama, and then pull, and then llama 2. Now I already have this, so it ran extremely quickly, but you can see it's about 3.8 gigabytes that it needs to download, so this will take a second if you don't already have the model. Again, in order for this to work, you're going to need to install Ollama on your computer. Go to the terminal, type Ollama, pull, and then llama 2, or whatever model it is that you want to use, and then we'll be able to utilize this model from our Docker container. Now, one other note here, if you are on Windows, you might run into some errors. So I'm going to leave a link in the description that discusses how you can run this with WSL. And you just need to make sure that you have Docker Desktop enabled with WSL when you're running these various containers. Again, I'll link this in the description just in case you have any issues, but it kind of discusses how you get Ollama running on Windows because it sometimes can be a little bit different than working with Mac or Linux. Okay, so now we're going to go back to the documentation here, and we're going to go to where it says add a local or remote LLM service. Now you can see that we can run Ollama in a container, we can run Ollama outside of a container, or we can use OpenAI. So we're going to go down here, and we're actually just going to click on run Ollama outside of a container, and we're going to use the Ollama service that's running on our local machine. So it says install and run Ollama on your host machine, which we are doing, and then update the Ollama base URL value in your .env file to be the following. So let's copy this value here. Let's go to our environment variable file, which I have open, and let's update the Ollama base URL. Now, while we're here, we're also going to change the sentence transformer to be llama 2, just so we're using the llama 2 model as well for our embeddings. Okay, let's go back and see if there's anything else that we need to do. It says pull the model to Ollama using the following command. We already did that, so if you didn't do that, go ahead and run it, but in my case I did, and now we should be able to run our GenAI application, and we should see that all of our services are running locally. So let's go back here. I'm just going to get out of whatever was running before. We'll rerun this, and then hopefully our application will be working fine. Okay, so I'm just going to paste in the command here, docker compose up, and then -- build. Let's give that a second to run, and then let's look at our finished app. So the app is running now, and what I can do again is upload a PDF. So let's go with the same one as before and then chat with it. So I'm just going to ask it what is the date and amount for this invoice, and let's see if it can get that result. All right, so there you go, June 24th, 2024. The amount is for $62. Obviously, we can chat with this more if we want, but I think that proves the point that this is indeed working. So there you go. That is how you deploy and containerize a GenAI application using Docker. Now, the last thing I want to show you here is a really interesting feature that can save you a ton of time when you actually are going into production, and that's something known as Docker Scout. Now, in order to use this feature, we need to open up Docker Desktop, which I already have right here, and we're going to go into our images here, and you can see that what we can actually do is we can click on one of them. So let's go to the GenAI Stack Loader, for example, and right away it's going to open up this Vulnerabilities tab. Now, this is a way that we can actually detect all of the known vulnerabilities in the different images that we're using, as well as the various dependencies. And not only that, we can actually see the solution or the version we should go to fix these vulnerabilities. So you can see on the right hand side of my screen here that actually shows me various different packages which are dependencies for this image, and it shows me all of the different vulnerabilities that they have, ranking by critical, high, medium, or low priority. Now I can actually sort by fixable packages if I just want to see the ones that do actually have a fix, but if you want, you can click in, you can see exactly where the vulnerabilities are, and then it actually gives you a description of what it is and shows you, if applicable, what the fixed version is. Now, in this case, there's no fix for this one, but if we go to this package here, cryptography, we can go to this one, and you can see that it will tell us that the affected range is this. And if we go up to 42.0.4, then that'll actually fix this vulnerability. So it's super fast and very easy to actually see the fix, which is the useful component of this, because it's one thing to know the vulnerabilities, it's another thing to really quickly be able to find what the solution is. Now, this Docker Scout feature works by analyzing all of the different images and dependencies that you have and then matching it against an inventory of ever updating vulnerabilities. So it already has all of the fixes, all of the vulnerabilities. They pull that from so many different places. And then they take all of your images and just match it against that, which allows them to really quickly give you all of these different recommendations and show you where the vulnerabilities are. A super useful thing and definitely something you want to check out, especially if you're going to go into production, and it's just built in here right to Docker desktop. So with that said, guys, I am going to wrap up the video here. All of the relevant documentation for this will be linked in the description. If you have any questions, leave them in the comments down below. I hope you found this helpful, and I look forward to seeing you in another video.